Insert Hereford Institute logo here, and fun, exciting music. Section 5.1, we're going to learn how to compare and order rational numbers on a number line. Before we begin, we're going to talk a little bit about some vocabulary words. First of all, what is a rational number? A rational number is a number that can be written as a ratio, which is a quotient, of two integers, a and b, where b does not equal 0. For the first example, we want to see if 1/9 is a rational number. First of all, let's put this into a ratio. Before we get there, we have to first put it into a fraction. So we would change that to 1 9/10. After it's as a mixed number, we want to change it into an improper fraction. So it's going to be our 10 times 1 plus 9 all over the denominator 10. So that would give us 19/10. And if I can't simplify it completely anymore, then that is my final answer. Let's make sure that it's checked. Can it be written as a ratio? Yes. Are both of those numbers integers? Yes. And is the denominator not 0? Yes. So 1.9 or 1 9/10 is a rational number. For the next example, we'll try a negative number, and let's check to see if this is a rational number. -4/10. So again, first of all, let's write it as a fraction. So that's going to be -4, and it's in the tenths place. And here, since it's already as a mixed number, the denominator is not 0. But what do we need to do here? That's right, we need to simplify completely. So we're going to divide both the numerator and the denominator by 2. And we're going to get an answer of -2/5, or which is our -0.4. Check, so it does check out. So I guess you don't really need the last part because you wanted to see if you can put it into a rational number or as a quotient of two integers. And you did, so you're done. Yes, -4/10 is a rational number. So following those two steps, you can find out if a number is rational. Can you put it into a ratio or a quotient, and does it meet the requirement of both of the numerator and the denominator are integers, positive or negative, and the denominator is not 0. Now it's time for my favorite part. Since we all learn best by doing, let's go ahead and do the you try too. Get it? It's two like two problems, and two like also two. That's funny. Try these two examples and pause, play when you're ready to check the solution. Check your solutions and then keep on going. By the way, that was part 1, identifying rational numbers. And really, you just need to ask yourself a question that can you put the number into a rational or ratio? Get it? Ratio. And if you can, then you are good to go, and it is rational. For part 2, we're going to graph and compare rational numbers on a number line. Before we start, let's do a mini review of number line. First of all, we know that a number line is not just a line segment, but a line, so we need to make sure it has arrows because it extends in both directions infinitely, and it needs to have some kind of scale markers on it. Once you have your markings, then you need to assign value to said markings so that you can graph numbers on them. On your graph, your negative numbers go to the left of 0 and your positive numbers go to the right. But you also want to remember, for a number line, you don't have to graph the whole number line. You want to make sure that you look at the numbers that need to be graphed and figure out your range and scale before you actually assign values to your scale markers. Alright, I think that's a pretty good review, so let's continue. The final thing I want to mention is the numbers on the number line. The number that's on the left is the smaller one. So if you're playing with positive numbers, you want to check to see which one is closer to 0. And if you're playing with your negative numbers, you want to check to see which one is further away or to the left of 0. So let's go ahead and try a couple examples. Two things you want to remember is what is the range of your graph, what are your endpoints, and what is the scale markers that you're going to put on your graph. When comparing two numbers, we want to make sure they're rational, for this section anyways. But before we do that, you either want them all to be in decimal form or all to be in fraction form. Just makes things a little bit easier. You don't have to do it, but it just, like I said, makes things a little bit easier for you. I'm going to choose to go decimal form on this one. So now that we have -3 and 9/10 and -5 1/2 or 5/10, I'm going to figure out what our range and scale are going to be. I'm going to say my range for this guy, I'm going to do -3/10 to -3/5, and then I'm going to do a scale of 1/10, and I'm going to keep it negative. So the number line, notice that I'm going to draw is all in the negative quadrant. Draw my line with my arrows and 2, 3, 4, 5, 6 markers. Then I'm just going to mark a couple of them so I know where I'm going. Once on my scale markers, then all I need to do is just graph them. So -3/5 will then be here. I'm going to graph it on the number line and then write the value above it. And then I'm going to go to 3/9, -3/9, and then I'm going to write the value above it. And that is how you graph those two numbers. So your final solution then would be that -7/2 is greater than -3/9. Now you try 2/5 and -3/10, and the second one 1 4/10 and 5/4. Remember, decide whether you want them to be in fractions or decimals before you compare. Figure out your range and scale and graph away. Compare your answers and you're good to go. Ordering rational numbers is just like ordering pairs of numbers. You just do more of them and then you put it on the number line. Oh, it's big and small and I don't know what's happening. But that's exciting. So your plan of action, or in this case your plan of attack, is to sort the numbers in order from least to greatest, determine the range and scale, and then graph on the number line. I'll do one example and then you can try. First, you're going to put everything in the same form, in this case, all decimals. Then, putting them in order from least to greatest, range and scale. Draw your line with your scale and your arrows, and graph. Graph them on the number line with approximations, and you're done. 2 you tries, you try 2. So then you put everything on a number line, and you can compare the digits to each other if they ask you to, but they might just ask you to put them in order. And then you're done. Yay.